Okay, geometry guys, we're looking at 4.1. We're looking at the beginning of unit 4. We're talking about polygons. So now remember, last unit was all about triangles. So now we're taking it one step further and talking about polygons, which is shapes with more sides than 3. So you need to be able to identify and classify polygons, figuring out what a regular polygon is, and then use properties of interior and exterior angles to solve the problems. So polygons are a closed figure made up of sides. These sides intersect at endpoints. There's no intersecting side. So quick example, the left side are polygons, the right side are not. Notice that the left side I've got closed sides, okay? There's no opening and there's no overlapping. The right hand side has got two shapes that are open and one shape that overlaps. There is none of that in a polygon. So if I've got a polygon, the number of sides would be 3. The number of triangles created will be 1. The sum of the interior angles. It is a triangle, so that means it's going to be 180. The measure of a regular interior angle. So if it's regular, that means all sides are equal. Are all sides congruent? All angles congruent. So the name we know for a regular triangle would be equilateral or equiangular. So the measure of regular interior angles would be 60, 60, and 60. So the measure of a regular exterior angle, remember exterior angle has got to add up to the other two sides. So that's going to be 120. That would be 120. That would be 120. So the measure of each regular exterior angle would be 120. The measure of each interior angle is going to be 60. All right. A polygon with 4 sides. How many triangles can I create there? Well, no matter where you draw, if I draw one diagonal there, I get 2 triangles. Even if I draw it diagonal to diagonal like that, that's still 2 triangles. So the sum of the interior angles, well, this is 2 triangles. Each triangle's got to be 180, so that's 180 and 180. So the sum of the interior angles has got to be 360. All right, that's 2 triangles. So that's going to be 360. The measure of the regular interior angles. Well, if they're all congruent and all sides are congruent, that's going to be a square. So each one has got to be 90 degrees. So the measure of a regular exterior angle, well, if this is 90, this is going to be 90, 90, 90, 90. You kind of hope you deal with squares because squares have a lot of stuff true of them and you can solve for a lot of things. So the measure of a regular exterior angle is going to be 90 degrees. All right, now be aware, what do all these exterior angles add up to every single time? So keep that in mind. So a polygon with 5 sides, we call that a pentagon. Pentagon. So how many triangles can I draw? Well, there's 5 sides. How many triangles can I draw? It doesn't really matter where I draw it from. So if I take it from the top, 1, 2, that's 3 triangles. So that's 3 times 180. So that's going to be 540. So if it's a regular, that means all sides are equal, all angles are equal. I got to take 540 divided by 5. So that's going to be, each angle is going to be 108 degrees. So if each one in here is 108, then on the outside, that's got to be 72 degrees. So 6 sides. Hopefully you're starting to see kind of what we're talking about. 6 sides, that's called a hexagon. So how many triangles? Well, it doesn't matter where I start from. Just draw the diagonals as many as you can. That's 4 triangles. Are you guys noticing that the number of triangles is always 2 less than the number of sides? That's not a coincidence. So I need 4 times 180, and that's going to be 720. So if it's regular, all of them are equal. All the sides are, all the angles are equal. So I need 720 divided by 6. So that's going to be 120. 120 times 6, 720, yes. So that means each angle is 120. So that means each exterior angle is going to be 60. So you're noticing some patterns that emerge here. So kind of a generic polygon, you know, if I got the number of sides is just n, the number of triangles is always going to be n minus 2. The sum of the interior angles was always the number of triangles times 180. So that's going to be n minus 2 times 180, where n is my number of sides. The measure of the regular interior angles is where you take n minus 2 times 180 divided by my number of angles, which was also my number of sides. So the measure of the regular exterior angles, well, I've got n number of angles, which means I've got n number of exterior angles, but the sum of regular exterior angles is always going to be 360. All right, so if you go back and look, go back and check, all of the exterior angles, if I added them up all the way around, was going to be 360. So take a look at this. So exterior angles have to add up to 360. So if I've got a heptagon, heptagon means 7 sides. 7 sides means 5 triangles. 5 times 180 is going to be what? What's 5 times 180? 5 times 180. I get that to be 900. 900 degrees. That is my heptagon sum. So that's 18 sides for an 18gon. That's 16 triangles. That's 16 times 180. All right, I'm not that good. I'm going to grab a calculator quick and do it on that. 16 times 180. I get 2880 degrees. So 2,880 degrees would be the interior angles sum of an 18gon. So we have got a 4-sided figure. That is a quadrilateral. That is 4 sides. That is 2 triangles. So that means my sum is 2 times 180. That means my sum is 360 degrees. So that means that this, and this have to add up to 360 degrees. All right, by rule. It's a quadrilateral, has to follow that side. So 360 degrees. Well, I know this is 90. I know this is 90. I can take those away. So 360 minus 90 is 180. So that means 3x plus x can only equal 180. So 4x equals 180. X has got to equal, let's see, 45. So x is 45. So this is 45. This has got to be 135. Okay, look at this big mess. So we have a pentagon. Pentagon's got 5 sides. That's fine. We're assuming that there's some are, some are not. Oh, they are. Okay. So my sum, 5 sides, 3 triangles. So 3 times 180 is 540. So that means all of these together equal 540. So 2x plus 2x plus 3x plus 14 plus 3x plus 14 plus 142 all equals 540. So let's shorten this up quite a bit. So 2x, 2x, 3x, 3x. So 10x, 14, 14, 142. 14, 14 is 28 plus 142 is 170. That's going to equal 540. So a little solving. I get x to be 37. So I get x to be 37. Once x is 37, you can substitute it in here, substitute in here, substitute in here, substitute in here, and you can figure out what those angles are going to be. So if the measure of the interior angle of a regular polygon is 135, find the number of sides that the polygon has. So we're looking for number of sides. So the interior angle of some polygon is 135. So we know that the regular sum is going to be 135. So here's what I use. I use this guy because this is going to tell me exactly what each one is. So I know 180 times n minus 2 divided by n is going to equal 135. So if I multiply both sides by n, just old school algebra stuff, that cancels out. I'm going to kill two birds with one stone. I'm going to distribute that. I get that. Subtract 135 over, 135n over, add 360 over. So 180 minus 135 is 45n equals 360. So n is going to equal 8. So that means that that is an 8-sided figure. Okay, that is the number of sides, so that is going to be an octagon. Holy cow, look at this big mess. Well, notice how these are all exterior angles. Exterior angles always add up to 360. So that means I'm going to add all of this and set it equal to 360. So I got 5x plus 5, 5x, 4x minus 6, 5x minus 5, 4x plus 3, 6x minus 12, 2x plus 3, all that's got to equal 360. All right, now that's a lot. Let's start putting some things together here. 5x, 5x, 4x, 5x, 4x, 6x, 2x. 5 is 10, 14, 19, 23, 29, 31x. 5 minus 6 is negative 1. Minus 5 is negative 6. Plus 3 is negative 3. Minus 12 is negative 15. Plus 3 is minus 12 equals 360. So that means 31x equals 372. Little division, I get x to be 12. Do you see how about 85% of this battle is in the setup? Once you get in the setup, then life becomes easy, but you've got to kind of recognize the situation that you've got. All right, what is the measure of a regular exterior angle of a regular decagon? So a decagon's got 10 sides, so that's going to be real easy. 360 divided by 10, the exterior angle measure is going to be 36 degrees. So, big difference. Convex, concave, polygon. Yes, these are still polygons, even though they kind of go in. The way you remember it is this. Concave makes a cave. So you look, this is like a cave. This is like a cave. I go in and back out, but I'm still connected on the side. Convex makes no caves. Convex does not go interior, exterior, or not. So concave makes a cave, means you go in and then you come back out the shape. That's all I got. Come talk to me with questions.